All right, today we're going to talk about solving linear inequalities. First, let's define what is a linear inequality. All it is it's similar to a linear equation, but it utilizes inequality symbols instead of an equal sign. And then, since we're talking about solving linear inequalities, we also should define what a solution to a linear inequality is. A solution to a linear inequality is any ordered pair that makes the statement or makes the inequality true. So in our first example, we're going to decide if the ordered pair is a solution to the linear inequality. We're going to look at two different examples here. So we're going to look first at A. We're going to ask, is the ordered pair 7, 3 a solution to y is less than x minus 1? And what we're going to do is we're just going to substitute 7 and 3 into our equation for x and y, since an ordered pair is written as an x and a y coordinate. So let's do that. We're going to ask, is 3 less than 7 minus 1? 7 minus 1 is 6, and 3 is less than 6, so that means 7, 3 is a solution. Let's look at one more. Let's see if the ordered pair 4, 5 is a solution to the inequality y is greater than 3x plus 2. So again, we're just going to replace the x and the y with 4 and 5. So we're going to see, is 5 greater than 3 times 4 plus 2? And if it is, then this ordered pair is a solution. If it's not, then it's not a solution. Well, 3 times 4, that's 12. And 12 plus 2 is 14. I don't think 5 can ever be greater than 14. So that means the ordered pair 4, 5 is not a solution. And we've finished example 1. All right, now what we're really going to be looking at in this lesson is graphing these linear inequalities, and there's some things we need to just take note of. So copy this graph down with me. We don't have to worry so much about these lines being super accurate, but I do want us to have an idea of what these parts mean and how they would change based off of any scenarios or situations we look at. Okay, so I'm going to now just label some parts we have here. We have this solid gray line I drew. If we have an inequality where we have y is less than or equal to, or if we have one that's y is greater than or equal to, when we're graphing, we're going to have to graph a solid line. from the expression that y is being compared to. On the flip side, this red line, dashed line we have here, we would make our lines dash if we have y is less than or y is greater than. The reason between those two differences, a solid versus a dashed line, is the solid line tells us that we need to include all the points on the line. If we use a dashed line, that means those points will not actually make the equation true, but they are a boundary to that. Then we also have here in this kind of maroon color some shading that I did. Now when I shade above my line, that means I'm going to have an inequality that's y is greater than or an inequality where y is greater than or equal to. I'm shading above the line because those are the values that are greater than that line. And the opposite's true then here in blue, where I shaded below the line, I'd have y is less than or y is less than or equal to. So I'm going to give you a few steps on this next page on how we would graph linear inequalities before we actually look at an example. Alright, so our steps for graphing linear inequalities are as follows. The first thing we're going to do is solve the inequality for y. We're going to put it into slope-intercept form, y equals mx plus b. Once we've done that, we're going to graph the boundary line. So whatever y is either less than or equal to, greater than or equal to, or whatever, we're going to graph that line, and then we'll use a solid line for ones where we have the less than and equal to or the greater than and equal to. And then we'd use a dashed line for cases where we have less than or greater than. Finally, what we would do is shade the half plane, or shade the portion of the graph, either above the line for cases where we are greater than or greater than or equal to, or we would shade below the line. And I forgot to put the line after above before. So we'd shade below the line if we are less than or if we are less than or equal to. So those are the steps. Let's look at some examples. So in example 2, what we're going to do is graph y. We're going to have two examples within example 2. So our first one is going to be y is less than 3x plus 4. Now, it's already solved for y, so we don't have to do step 1. Step 2, we're going to pretend that we have y equals 3x plus 4 because we're going to graph the boundary line. So let's make our xy plane. My y-intercept is going to be at 4, so I'm going to go up 4 from the origin and put a dot. And then I need to move either up 3 and right 1, or I can also move down 3 and left 1 to put in a couple more points. So we've got that started, but now we have to ask ourselves, are we going to use a dash or a solid line when we connect this? I do not see that y is less than or equal to. It is just strictly less than. So we are going to use a dashed line, and we're going to do our very best to make this dashed. In fact, I would recommend in your assignment making a solid line and then going back and erasing bits of it. So we've got the boundary line graphed now. Since this inequality says that it's less than, we have to decide, are we going to shade the region that's above our line or below our line? Well, anything that's less than is below. So what we're going to do is we're going to shade all the parts that are below our line. And actually the graph there is then our answer. So we're actually done with example 2a. Let's look at graphing another inequality to see how it still works. So this is still example 2, but this one's example 2b, where we're going to graph 3x plus 2y is greater than or equal to 6. Now, we do have to solve this one for y. So I'm going to start by subtracting 3x to both sides. So I'm going to have 2y is greater than or equal to negative 3x plus 6, because I do want to put this in y equals mx plus b form. Just the equals will be the inequality. I've got one more step to get y by itself. I'm going to divide everything by 2. So I'm going to end up with y is greater than or equal to negative 3 over 2x plus 3. So we've got step 1 done. We've now solved for y. We can start the graphing process. So we make our xy plane. My y-intercept is the plus 3, so I'm going to go down 3 and put a point. And then my slope tells me I should go either down 3, right 2, or I can go up 3 and left 2. Now the question is, we've got some points. Are we going to make this a solid or a dashed line? I do see that this is y is greater than or equal to, so it's got that little line under the inequality symbol. We're going to connect our dots with a solid line. Okay, now we've done step 2. Step 3 is deciding which direction we're going to shade. We're going to go above our line or below our line. And remember, we go below if we have y is less than or equal to, and we go above when y is greater than or equal to. And since I see that y is greater than or equal to, I'm going to shade everything that's above my line. And then the graph, again, is our answer. So we're done with example 2. All right, let's look at one more example. We're going to call it example 3. We're going to do one where we have, say, y is less than 3. That's it. Y is already solved, so what we're going to do is make our xy plane. And when we have y is anything to a number, that means we're just going to have a horizontal line through that number. So we're going to go to 3, and we have to ask ourselves, are we going to make a solid or dashed line? I don't see that the inequality symbol says or equal to, so I'm going to make a dashed line. And then we decide, are we above or below the line with our shading? Since y is less than 3, we're going to shade everything below the line. Let's look at one. We're finished with this one, so let's look at one more example, and then we can be done. So this is still going to be example 3, but this is going to be 3b, where we're going to have x is greater than or equal to negative 2. So there is no y in this case, but we don't need that because we should recall from earlier in the year when we have x equals a number, it's going to be a vertical line through that number on the x-axis. So let's make our xy plane. And I'm actually going to switch colors for making my line so we don't get confused. We have x is greater than or equal to -2, so we're going to go to -2 on our x-axis, and then we decide, is this going to be a solid or dashed line? Well, since it has the or equal to, we make it a solid line. And since it's x is something to a number, it's a vertical line. Now we have to decide shading. Well, when we have a vertical line, we can't really shade above or below it, but we can shade to the left or right. So we have to ask ourselves, is the left numbers that are bigger than -2, or is the right? And when I look at this, I know numbers that are to the right of -2 are larger. So when I have x is greater than or equal to -2, I'm going to shade everything that is to the right. And we're actually going to wrap up and say we're done with this lesson on solving linear inequalities.